In this first lesson for Chapter 2, we're going to talk about variables and memory management. In Lesson 2, we'll talk a little bit about enhanced formatting tools as well as program design. Variables in computer science are very different than variables in math, yet they have very similar characteristics. In computer science, variables are used to set aside locations in memory to store the information needed for processing our program. You know, whether it's inputting names, numbers, scores, and then using them to calculate our scores, and then storing them again into other variables. The address of a location is always given a name. And that name generally is relative to the information being stored in it. The values within the variables can be overwritten through assignment or also through input. Now, when we had variables in mathematics, they just represented an unknown value, but that's not how variables work in computer science. We determine what the value is, and we use that variable as the address in memory from which I can retrieve that information or even store that information. So although they have a similar idea, they are really rather different. Variables in BASIC have two different data types. Now, variables in other languages, there are more data types, let's say in Java. There's like 5 or 6 data types in Java. And in BASIC, we use 2 data types. Now, the data types are used to let the computer know what kind of information they are processing, what kind of information stored in that memory location. And so the first type would be the literal, the string. That's the set of characters. That would be storing Mrs. Kiskadden into a memory location of the computer versus storing, a student test grade, that they got a 98 on a test. That might be represented by a numerical value. So my variable has to represent numbers. So the idea of 2 different data types. We use data types to manage our memory so that, we know what kind of information is being stored in there and how much information. And we'll see that if you continue to take computer science and study other languages. Now, there are rules for naming these variables. It must begin with a letter. And these are words. These, we're going to create variables that can be words. They can be single characters like we use in algebra. In algebra, we used an A, a B, an X, or a Y. But in computer science, I can actually use words, and we wouldn't see that in algebra. They have to contain only letters. It can't contain special characters. It can contain a letter and end with a number so that if, let's say, I had variables that were relatively the same, I could differentiate from one number from another number. Variables which hold text strings must end in a $sign, and that's included in the length of my variable name, which has to be 8 characters. It doesn't have to be 8 characters, but it can't be more than 8 characters. It can be 1 character long up to 8 characters long. And it can't be the same name as a keyword. And we mentioned that back in Chapter 1 that keywords were reserved words of the language. And so when I create my variables, I can't use keywords. So here's a list of possible variable names. You can see they vary in length. They also vary in symbols. Okay, so in this example here, like the idea of having 2 different cars, they end in a $sign. So based on the rules, that means that these are going to hold characters. Okay, so maybe these are holding the type of car it is, like a Ford versus a Chevy. And so I might use an identifier like A and B or 1 and 2 to say that A car represents, this car, I'm talking about the Ford, but B car represents the Chevy. So we can do that. Now I can use a number. So maybe I have a number here, and I can use that in the same way that I did the letter A and B. Bottom three would represent numbers. So the idea that we have string data types because it ends in a $sign, and then the other ones are constant data type. So only characters. Now, what you need to remember, though, is that numbers are characters. So this might be one I would use to store a telephone number because I can treat them as characters. We don't generally math with a telephone number. However, these down here can only be numbers. Things that I'm going to store. They can be decimal numbers, they can be whole numbers, but they can only be numbers. So how do I get information into a variable? So the first of those is using the keyword let. We use the keyword let to assign values to a variable in a memory location of the computer. And how that happens is that the math expression, okay, is going to store the information using the assignment operator into a variable location in memory. And so we always store from right to left. So the assignment operator looks like the equal sign. It is the equal sign. In algebra, remember the idea that x is equal to 2. Well, I can say x is equal to 2. Okay, but then x is going to be that address in memory from which I assigned the value to into that memory location. But we assign it from right to left. So if I wanted to put in my name, I would have to assign it on the right-hand side so that it stores it into the memory location named $sign that's on the left-hand side. So assignment operator, it is not treated as a standard equal sign for testing. We use it to test for equality, but we don't use it, like we do in algebra. But the idea that we always assign from right to left, that will be important. Order matters in computer science. So here are some examples. Here I have my line number. Here is my keyword. And it's saying to let something. So what do I want to let? I'm going to allow 3.14159 to be assigned into the memory location pi, this value. So anytime I want to use this number, I can just call on this memory location. And we can see that here. Here I'm letting the memory location area equal whatever is stored in the variable length times whatever is stored in the variable width. These are memory locations. Okay, these are memory locations. Here I'm allowing Mary to be placed into the memory location first $sign. So how might that look out in the computer? So in line 10, we're going to let the memory location called miles equal 149. Now, the way the computer does this is it just randomly chooses a location. It doesn't necessarily put them consecutively. We will learn a structure that will store them consecutively later on in the year. But so for instance, it just plopped it. This address here is miles, not the 16. Miles is the name of that memory location. So anytime I reference this variable, it will reference the number 149. In line 20, it is going to assign the memory location called X, the product of 8 times 9, which is the 72. So this is the memory location of X. Take notice they aren't necessarily connected side by side. So what's going to happen in line 30 is it's going to let a variable called total equal to miles times X. Miles is 149. So what it does is going to take a copy. It takes a copy from the memory location and it multiplies it by a copy in the X location. So it's going to actually multiply 149 times 72, which is this really big number, and it's going to store it. It's going to just randomly choose a location to store it, and it's going to store that number in memory. In line 40, then, it's going to execute by letting first $ equal memory. So it's just going to pick a location, sign it the name first $, and it's going to store the name Mary into that location. Okay, so although memory is really sort of this kind of organized structure in there, the way it assigns it is not, and it knows what to find based on the variable name, the identifier. It identifies the memory location miles, and it will retrieve from there a copy of what's stored there. So 149 will always stay in this location unless I overwrite it. So if I created another line of code and I said miles is now equal to 0, as I go through each executing line, eventually it will overwrite this memory location with 0. Okay, it will overwrite it with the ID of 0. Another way that I can assign information to a variable is through the keyword input. This is the first time that the user themselves, the client, will be able to, through the keyboard, input information into the computer. This is the first chance that we have to perform this action of getting information from the user. So it will prompt the user for information, and it will store it into the variable that's in the input line. Both string and constant data types can be used with the keyword input. What input is really a upgraded, enhanced version of a let statement because it will allow us to put a prompt to the screen specifically asking for information. So let's take a look at that. So here I have my keyword input, and this allows for a prompt. So this is what's going to display to the screen. Please identify yourself. And so this is the variable that the system is going to input from the keyboard. Once the user hits the enter key, everything it types, Mrs. Kiskaden, is going to get stored in this memory location as I demonstrated in a previous slide. Then it goes on and asks for input for gallons used. So this is looking for a numerical data type. So this will accept anything. Okay, this accepts anything from the user, even numbers. This only accepts numbers. Okay, because it is of numerical type. If you try to use letters and type Mrs. Kiskaden in there, it's going to give you an error. But what will happen is, as it executes, it's going to say, please identify yourself, and the cursor is going to sit there waiting. And it's going to wait for the user to type something and hit the enter key. Once I hit the enter key, then Mrs. Kiskaden is going to get stored in memory of name $, and it's going to go on to the next executing line of code. And from there, then, it's going to prompt the user to input another value, and the cursor is going to sit there waiting. And once I type a number, hit the enter key, it's going to take that and store that into the memory location called gallon for later use.